battle of a this painting of a battle somewhere, and you want to find out similar paintings elsewhere. How do you go about it? You'll go online and search for battle keyword, and it will give you some results. Those results will have either battle somewhere in its title and description. What it won't have is these paintings. These paintings are related to battle, but don't have the battle keyword in there. They have the keywords like war, raid, or a struggle somewhere. So using so what if you want to get these paintings also in the results that you got? This is where our system Totem Museum comes to your rescue. Using our system, you will get these paintings also in your result set. It does a semantic matching based on the theme, and gives you these paintings in the result set. Next, we have done extraction from 3 museums: the Art Institute of Chicago, LACMA, and Detroit Institute of Art, and used Pearl for scraping. We have attempted to do maximum of preliminary cleaning in the Pearl itself, but the data was still unclear and not properly formatted. To further clean the data, we used Google Refine. As you can see here, in the painted year, we had some garbage values which we cleaned using Google Refine. Also in nationality, we had the birth year and death year appended, and we had to split that column into 3 columns. This is how we used Google Refine. Next, we got some data about artists from DBpedia, and we linked it using Frill with our museum data based on artist name, birth year, death year, and nationality. This the update we gave for artist name was 60, birth year, death year 15 each, and 10 for the nationality. We used OpenCarry to identify all the named entities such as person, location, and organization from title and description. We did this as a pre-processing step for our tokenization phase. We tokenized the title and description of a painting and eliminated these entities. Is one of the after tokenizing, we found out that we had the issue of stop words, and we eliminated those stop words and using some standard stop words, and we further eliminated those stop words using TF IDF, and got rid of all the low value frequent words that were occurring, and got the high value rare words in our JSON. Those high value rare words synonym we obtained using WordNet Java library, so that we could classify, so that we could compare it with our classifier, which is battle in this case.
So as you can see, the synonym of a particular title had battle. We would store all the synonyms like conflict, fight, engagement in the JSON object, which we have already extracted and cleaned. After eliminating the stop words and adding synonyms to the JSON object, what we had to deal with the stemming process, because in case if the issue which we faced was if the terms battle and battles were not matching using our WordNet similarity algorithm, which we used for classification. We used a similarity algorithm called HSO, which is Hurst Trojan, which calculates the similarity score based on the census of the words. So the reason we went ahead with HSO algorithm is due to it gave us better and consistent results based on the different algorithm which is part of the WordNet similarity algorithm. This is a visualization where battle is our root node and the other adjacent nodes being the museums, and you see the paintings being connected. When the user clicks on one of the painting, you see about the painting description, other relevant details. The user can toggle between the graph visualization and also the slideshow visualization. Apart from battle-based classification, we also did classification based on scenery and still life. Scenery includes, okay, the painting background had a seascape or landscape or ocean or sea, and still life depicts about the actual inanimate objects or the uncommon objects as part of the painting. So apart from theme-based classification, we also did clustering based on the artist name, painted year, and the painting medium. So here we have used the standard k-means clustering algorithm. So the distance measure we used is string matching measure, For example, if we take the artist clustering, this artist Augustus had different representations. We used Jara-Winkler algorithm with a threshold of 0.94 to link these different records and group the paintings based on the same artist name clustering. Similarly, for medium-based clustering, we used the Smith-Waterman algorithm with a threshold score of 0.7. Here, the bronze is a superset of painting medium, and the other subset being the glit bronze or bronze with silver and gliding. So we had to deal, we felt Smith-Waterman is the best fit because it calculates based on local alignment. In the paint area clustering, we had to deal with two issues, mainly circa and the range. With circa, what we did is we added plus or minus 5 years to the actual year and clustered the paintings, and also with range we have considered the painting which falls within the range. The issue we had is the precision, and we calculate the precision and recall score based on battle classification. The recall score was around 100%, but the precision score was 80% because if the battle classifier was matching with the synonyms of field and front, which gave us battlefield and battlefront. Similarly, we also faced the challenge of with the classification of still life, where the synonyms of still and life is if those two terms are part of the title description, it was matching as still life, though it is no way relevant to our classification. The other thing we faced issue we faced is with the Unicode encoding, where we have addressed it based on the ICU4J Java library. So that's it.